Okay, I think everything is set up. I hope the lighting is fine and I hope you can hear me, and we can start. We can start with the July version of the Talking Mass Animation Generation collaboration. The prompt for this month is reflections and rotations. Create an animation showing that a reflection followed by another reflection is equivalent to a rotation. And the first thing I want to do is to just animate this process and then talk about why this is true maybe at the end. The important thing is that if these two reflections are parallel, like the lines at which we do the reflections, if they are parallel, it will be a translation and not a rotation. So they have to intersect. And if you want to do write down some algebraic equations, it's probably best to let those lines intersect in the origin and everything is easier. But we don't have to make that so complicated. We will I will center everything around the center of our canvas, and let's do the process itself first. And to do so, I have, where is it? I have this Pikachu image here, which I want to use because it's quite asymmetric, which should make everything more obvious when you flip and rotate things. So let's get that started. So I'm using, as always, I'm using Cindy.js with my my custom animation package. But before we get into animations themselves, let's try to make the Pikachu. If we want to draw images, we have to do reference points, and because the mirroring, the reflection, we want to have two reference points. So let's go into the rendering part and let's say draw image, and maybe we have two reference points. So A is so I want to have the canvas center as the center of our operation. So we want to have the canvas center. We go a little bit up and a little bit to the left. So maybe something like this. And something like this as our second anchoring point. And then first of all, we draw A and B as a little bit of debug. And then we draw our Pikachu. Now I have to remember in which order. I think we have to have points and then the name of the image. So we have A, B, Pikachu. And that works perfectly fine. It's just that these points are too close to each other. So let's move them a little bit up. So first of all, as a reference, let's draw the canvas center too. And let's make those much further apart. So let's say 4 and 4. And well, maybe 5 and 5. And move them up a little bit more. Oh yeah, okay, that's... So this is our Pikachu image, or the first one. I think we will have copies of the image. And now we want to have two lines. So the first line, as I said, I want to make everything centered around the canvas center here. So let's make the first line go off to the top left somewhere. So let me think about what we want to do. We want to have a line itself, and then I want to have the reflection. For the reflection, I need the normal vector of the line, I think. So what I'm thinking about is now we want to have the geometric representation of the line we can use for our reflection calculations, and we also want to have something we can draw, and maybe that's not the same. So let me have a think about this. So yeah, let's start by have normal vector 1 and let's say if the line goes maybe 140 degrees, maybe we have 50 degrees for the first normal vector. And how do I want to draw it? I want to make a line object up here. So let's say the direction one, so let's also have the direction of the line. This is the perpendicular of the normal vector, and then we have the canvas. So let's say line 1 is new line, we say canvas center minus 5 times the direction, and canvas center plus 5 times the direction 1. And then let's say make the line appear as our second step. We let the Pikachu appear in a moment, and then we want to draw the line. The line is at the bottom of everything probably. So we have line 1 draw. Quick test, doesn't work. Oh, dear 1 ink, line 1. Yeah, something like this. It's just too small, right? Do I have? Let me check. So we can make that 15. Right. Or let's say minus 10 to 20 or something like that. So this is the first line, and then we let the Pikachu appear. Let's do that right away. Where's the image? Can I scale this? Can I scale this? No, because I have 2 anchoring points. That's okay. So how do I want to make the Pikachu appear? By animating A and B probably, right? So let's do that very lazily here in our calculations. We want to have this one. So we want to have, let's call it W. W should move from 0 to 6 by is out back. T1, so T1, T2 are always the references to the movements, to the animation tracks in my package, and now we should get something like this. Maybe not the prettiest, but that's okay. So let's get rid of those debug points. We have a Pikachu, we have one line, and then we have a second line. So let's paste the next line. Let's make it 45 degrees more, maybe. normal to, direction to, line to, oh yeah, maybe we should we have Pikachu and we have our two lines. Oh yeah, 45 degrees is... Will that work? We will see. So let's revise our plan to make this the canvas center. Let's make it a new point. Origin is canvas... What is going on? Canvas center. Let's move it a little bit to the bottom right, then we have more space. Right. And let's make it 40 degrees. Maybe that's okay. Okay. And now we want to... Now I'm thinking about, do I want to have an arrow which indicates that it is a flip, or do I want to just have the flip? And now I'm thinking about, I want to have the original Pikachu, and I also want to have the reflections. So we want to have copies of that. So to do that, oh, first of all, I'm working on a little something that makes this a little bit nicer. I'm calling it a ladder, which stupid name. So I want to have the lines to be animated with a little offset. So it's the second motion with two objects and a little bit of separation. And then I can write something like this in my package. And then they are offset a little bit automatically. Right. And now we want to move them. So let's go over here and say current track index is 3. So we can start at the end. Fantastic. So to do the actual motion, I want to move the reference points and then the image should move with it. And for that I need the image points. So let's quickly look up reflection at line. How to find reflection. Let's copy it from Wikipedia. No. Spiegelung. Spiegelung, Mathematik, Geometrie. Fantastic. No formula. I know that I can derive the formula myself, but I won't make it correctly. So reflection across an arbitrary line through the origin in 2 dimensions can be described. Fantastic. So we have L is the any vector in the line. Oh, that's nice. Okay, so L is that correct? So L is our direction, not a normal vector. All right, so yeah, it's the other way around, I think. Right. Okay. So we have the formula. Fantastic. So let's say we have new points. Let's call them AA. Very uninspired. So AA is the reflection. So this is 2 times. And what do we have? We have A times dir1 divided by the length squared of dir1, which is already 1. So in CindyJS, which is very nice, it's built for linear algebra. So you can, if you have an expression that you write down with arrays and nested arrays, which vaguely resembles a an operation from linear algebra, it will work. So in this case, we have two arrays, and the product will automatically be the dot product, the scalar product, which is very nice. So let's get our points back, and then we have to times tier 1 minus a. So this should be double a. And that is, so this is a. And the formula tells me that this is double a. Whereas double a should be around here. So let's make the other formula, which is more reliable. So we have a minus 2 times the product, a times normal 1 times normal 1. It's the same, which is... Oh, the origin. Of course, the origin in Cindy.js is somewhere around here, so that's why it's like that, right? So we have to normalize everything. So we have to... So a is the position. Do I have to subtract the origin from everything? No, just the position vector. So minus origin plus origin. Right, that looks good. Now we can do that same with b. Now we have our... Where is it? Oh, we haven't drawn it. Yeah. Right, this is the reflected B. And now we want to have the Pikachu here. So a quick check whether it works is we were doing that. Right. Do I have to... Is that correct? Let's make both of them. It doesn't looks... Oh, you subscribed. That's very nice of you. Thank you very much. I'm not doing too much on YouTube these days, apart from these live streams, but I'm very happy to see the channel grow a little bit. I'm currently in the process of moving house, so there's a lot of stuff going on. So let's see whether we can make a few more videos at the end of the year. But yeah, welcome to the channel. So is this now the correct reflection on line 1? Let's you know, this was supposed to be super easy, but so let's make that. Oh, let's make that, yeah, red, because it's the first one, and that green. I am very confused. If I'm reflecting the reference points, the image should be reflected or not. Why? I'm very confused. Do I have to switch them? That's also not correct. I am very puzzled. Maybe this will take longer than expected. Oh my god. Why? And let's make that transparent. So if anyone can explain this to me, that would be nice. So we have the solid Pikachu spanned between the red points. And then we have the reflected points. So there is a 90-degree rotation missing, I guess. If we oh, I'm very rusty on my algebra. If you reflect the translucent Pikachu on the line connecting the reference points, it should look okay. Let's try that. So let's make new points. Let's take C and D. So what can I do with this function? Flip Y. Let me quickly go to the reference page. I always try to not prepare for these live streams because it's a more genuine experience, but then of course I'm stuck on stupid things that I should know. So we can have flip X. We can have flip Y. Right, and now this looks is this looking correct? This is looking correct, right? Okay, but now my right. So this is now correct. I cannot understand why. I should understand why, but that's okay. But now my plan was to move those anchor points here, which we use to draw the image, to interpolate them from the old reference points to the new reference points, which would move the second picture over. But since we have this flip in between, I'm not sure this will work now, but let's give it a try. So if you lerp from... Okay, let me give me a second. If we do that, then it's upside down as it should be. That's okay. Oh, that's very unfortunate. But that's okay. So if we have lerp a lerp b a. Oh my. Oh yeah, that's not good. I very naively assumed it would look like a mirror process, but that's maybe not the case. Why is it not? Why is it not? That is very frustrating. Can I... Where is my reference? What can I do? What to do. Okay. So it would be easier to have just points and then mirror those points so we have an abstract shape, but I really liked the idea of the Pikachu moving. Let me quickly see. Right, so the picture is so let me try something. Maybe it won't work. So origin plus let's see what happens if we use a third anchor point. So C is above A, and should be something like this, and then we can have, so the original Pikachu is drawn the same way with our 3 anchor points, and if we I don't think this will help, but I'm just curious what will happen. So if we now, what happens if we draw this Pikachu? Right, now this is correct without the flipping, because with 3 anchor points we can differentiate between the orientation of, or yeah, we can differentiate between the orientation in which the outside of the Pikachu is parametrized, basically. So this is 1, 2, 3, which is a little bit weird in CindyJS, that with 3 anchor points it is bottom left, bottom right, top left, and not around in a nice way. But with 3 anchor points now it works. So we should be able to lerp this. Right. Fantastic. This is what I imagined. Yeah. Somehow in my preparation I imagined that we need 3 anchor points, but somehow beautiful. And we let the alpha also interpolate from, we let it pop up. So let's make it ease out circ typing. And do we want to have it fully visible? Probably. Maybe? Let's make it 70% visible. Or 50%. Fantastic. That looks beautiful. And now we can get rid of our debug points. So let's make this clear. Right. not good practice, as I imagined. Fantastic. Now the question is, do we want to have this first mirror image? Do we want to ease it a little bit? Cubic. Why not? Then we make the movement a little bit longer. Looks good enough. So I talked about this in my other videos for this event. If you do easing functions on movements that represent mathematical transformations, it's sometimes not correct to do it depending on what you want to animate, whether it's an abstract idea you want to animate or a physical process. In this case, this flipping is the physical process and the underlying reflection is whatever. Right, and now we can get back to the second line. So we have one flip, two flip, three flip, four. So let's do it one more time. And obviously we will do it one more time. So we will take new points and we will reflect them on the second line, and what we have to reflect are the first reflected points. So this is A, B, C, C, and B. And then we draw another Pikachu. It goes from AA to AAA, from B to triple B, and double C, triple C. And we will have it, let's make that 7 and that 4. And it's the fourth movement. We want to have it afterwards and we want to have no pause between. So at the moment I'm setting it up that the pause is 0.1 seconds for this development phase, but for the final render we don't want to have any pause here, I think. Fantastic. And now the only problem is that it is overlapping. And we can work with that. And to do so, what we want to do is, I think let's move the origin a little bit further down. And let's move the Pikachu to the top right so that it is very close to the first line. And let's make the first line, where's the first line? Let's make it something like this. Already better. Now we want to move the our little Pikachu up. So we want to have let's make 5 and this is now very hacky. Oh no, wrong direction. Right. I do not mind that it has a little bit of overlap because that's quite insightful, I think, but it should be a little bit less. Let's make it somewhat extreme. Fantastic. Now the Pikachu is beyond the canvas. This is very fiddly stuff which doesn't really matter, but Right, and let's make the... Where's the second line? Let's make the second line a little bit angled. I think that's okay. Now we can... Fantastic. And the... Oh, give me a second. The phone is ringing. Right, sound is back up, so sorry for that. Right, and the last thing I want to do is to see that it is a rotation. I want to rotate it back. And to rotate it back, what do I want to rotate? I want to rotate the actual image or another copy of the image. In my mind, I want to rotate the actual image and make the middle one fade out. So let's try that. So that's number 5, movement number 5. So first of all, we make the second image fade out. So we ease in, out, now ease in, circ T5. So, oh, 1 minus T5. So we have flip, flip, and then it will fade out, right? So let's move up to 5. Is that the right fade out I want? I have ease in, which looks like this, and then I have 1 minor. It's okay. I think that's right. And now I want to rotate this thing here. And to rotate it, I want to, so now I don't want to lerp it. I want to show that it is a rotation. So I can't lerp the AAA back to the single A. I have to rotate it. So we have AA. Oh, and now like the big reveal, I guess, is what we have seen here. Let's look at it from the start for a second. So the big reveal is if you take 2 lines, you make those flips, you get a rotation, and the rotation is exactly by the angle between the lines or double the angle. I can never remember. We will find out in a second. So let's call that angle 1. And let's call that angle 2, then we can reference it. And now let me quickly see if the angle is, just for reference, it's probably twice the angle difference. So we want to what we want to do, and this is now a little bit easier because of the helper functions in my package. We want to rotate AAA around, let's try to remember, first the angle, I think, angle 2 minus angle 1, and then the rotation center, origin. And as I said, I think it's twice the angle, but let's see what happens. Oh yeah, first of all it's minus because we want to undo the rotation to get back to the original, and of course we want to move to ease that, not ease it, we want to animate it at all. So let's make it T5, and I think it's fair to ease it. Right, perfect. That's the first, so at least that I remembered correctly. And now it overlaps. And we want to do we want to do anything with the alpha? I don't know. I don't think so. So the last thing I want to do for now is I want to color the lines differently. So where is it? So first of all, we want to have the size a little bit different. I don't know, 4. Let's see how that works out. And we want to have the color. Fantastic, and this is a very simple animation now for why 2 reflections correspond to a rotation around the intersection point. Let's see, we stopped after 5, right? So let's render it out. I hope that works now. Let me. Oh yeah, we for this animation generation collaboration, I don't have my full render setup, so we have to do it by hand a little bit, but that's okay. Before I forget it, let's make a background. So fill, poly, canvas, poly, I think. Because by default it will be rendered with a white background. Fantastic. So we go to the render mode frames, and then we hop over to a Firefox based browser because that works better. And now we can hopefully see, if we double click, how all of our frames get downloaded. So they will get downloaded here to the download folder. Yeah, and then we can see how the finished video looks. What I would have loved to do is talk a little bit about why it's true. So the high level actual geometry reason why it's true is that a rotation is a distance preserving an orthonormal linear map with positive sign, and a reflection is an orthonormal transformation with a negative sign. But that's basically just the generalized definition of what rotations and reflections are. it's not something you can visualize, and also not something you can explain to, let's say, high schoolers in a good way. I talked to a couple of people on the server of Mass Exposition, and one had the idea to think about circles. So because if it's the underlying thing is that it's distance preserving what we're doing here, so it keeps the same distance to the center, so everything stays on a circle. And if you take 2 points on the circle and compare them, their distance stays the same. So if every circle stays the same circle and there is no distortion along the circle, it has to be a rotation. That's somehow intuitive, I think. And the other one is to look at the angle. So if we take let's say the foot here of the Pikachu and compare where it flips to. If you draw out those angles, you will see that it's always like the total angle that is moved is always the angle between those lines, and the angle between those lines is constant, so everything moves by this constant angle. This is also very nice, but I think it's a little bit too quick to get to the solution. And what I would have loved to do is to make some further animations for those 2 interpretations, the circle interpretation and the angle interpretation. But because of the phone call I got, and because it's already like 50 minutes for the Pikachu flipping, I will stop. So let's quickly go to the download folder and FFmpeg it. Oh no, oh, I don't have the, let me quickly, do I have it here? Oh, I don't know the command I'm usually using. So I have all the frames, but let me quickly see whether I can find the command I need. Is it here? It's here. Fantastic. Right, so we can FFmpeg is in the path, so you can also shove it into the download folder. Right, and now we have somehow VLC takes forever to start. Right. It's on repeat, right. So this is the final animation. And as I said, it's not a proof for what is going on, but I think at least it visualizes what's going on. 2 reflections correspond to a rotation. Fantastic, that's very nice. So thank you for watching. As I said, I won't do any proof animations, so homework, I guess. The code for this is in the repository as soon as I push it in a couple of minutes. And yeah, thank you for watching. I hope you enjoyed it, and we will see each other probably in August for the next animation generation collaboration. Until then,